So we've seen that we have this notation for ordered pairs. An ordered pair is a list x comma y, one object followed by another object in that order. Similarly, an ordered triple, same idea, is a list x comma y comma z. So three objects listed out in some order. More generally, a list of n objects, where n can be any positive integer, can be written like this. It can be written x1 comma x2 dot 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 all the way through xn. So we're taking the n objects, we're listing them out in some order. So for example, we have the first 5 natural numbers, which are 1 through 5. The numbers 1 through 5. Well, there are different ways we can list them. We can create different lists of those numbers. One possible list of the first 5 natural numbers is 1, 4, 3, 5, 2. So it's not an ordered pair because it's more than 2. It's not a triple, it's more than 3, but it's just a general list. Another possible list of those numbers, again, the first 5 natural numbers would be 5, 4, 3, 2, 1. Now, suppose we want to have a list x comma y comma z such that x is an element of the set of integers, y is an element of the set of real numbers, and z is an element of the set of rational numbers. Okay, so we want to construct a list, and we have these specifications that we want to follow. So if we want to create such a list, we have an infinite number of possibilities, because for x, we have an infinite number of possibilities, right? There are infinitely many integers. And certainly for y, there are infinitely many possibilities. So to construct such a list, there are infinitely many possibilities. For example, one possibility is the list -5, pi, 4/3, right? -5 is an element of the set of integers, an element of z. Pi is an element of r, of the real numbers. 4/3 is an element of q, the set of rational numbers. Okay, so we've seen this idea of lists. Now we're going to use this idea to talk about the Cartesian product. So we have a definition, the Cartesian product of sets S1 and S2. So if we have a set S1 and another set S2, okay, so these could be different sets, could be the same set potentially, but two sets, S1 and S2. The Cartesian product is written like this: S1 cross S2, and it's defined to be the set of all possible ordered pairs, x1 comma x2, all possible such ordered pairs, where x1 is an element of S1. Okay, so the first item in the pair comes from the first set, S1, and x2 is an element of S2. So the second item in the pair must come from the second set. And you should read the comma there in the middle, this comma, as like and, right? So it's specifying that x1 has to come from S1 and that x2 has to come from S2. So the idea is we want to create all possible order pairs that satisfy this these conditions, and we take all these ordered pairs and we put them into a set, and that set is called the Cartesian product of S1 and S2. Now, how about the Cartesian products of 3 sets? So the Cartesian product of sets S1, S2, and S3 would be S1 cross S2 cross S3, which is the set of all ordered pairs, the set of all ordered triples, x1, x2, x3, such that x1 is an element of S1, x2 is an element of S2, and x3 is an element of S3. So we're creating all possible lists of length 3, right? Ordered triples, where the first item in the list comes from S1, the second item in each list comes from S2, and the third item in each list comes from S3. More generally, the Cartesian product of n sets, if we have sets S1, S2, all the way through Sn, the Cartesian product of those sets is written S1 cross S2 cross ... all the way through cross S sub n. So n sets, the product of those n sets, the Cartesian product of those n sets, is defined to be the set of all lists of length n, right? So x1, x2, dot, 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 all the way through xn. So all such possible lists such that, meaning satisfying the condition that xi, each xi is an element of si for each value of I between 1 and n, right? So I is like a variable, like an index variable that ranges between 1 and n. And when we construct these lists that are going to become part of the Cartesian product, we need to make sure that each xi is an element of the corresponding si, the corresponding set si. Right? So for example, x2 must be an element of set s2. x15 must be an element of set s15. Right? And this must be true for each I between 1 and n. So for example, here we have 4 sets. Okay, so here's the case where n is equal to 4. So we have let A equals the set containing 1, 2, 3. B is the set containing 2, 5. C is the set just containing 6. And D is the set containing 3 and 7. And we would like to find A cross B cross C cross D. So following the definition, this should be the set of all lists of length 4, and we write such lists as x1, x2, x3, x4, but we only want to have those lists where x1 is an element of A, x2 is an element of B, and x3 is an element of C, and x4 is an element of D. Right, so that's the Cartesian product. Okay, so let's actually find it now. So the first thing we can think about is, well, if we want to create a list like this, the first element, x1, has to come from A. So let's say it's 1. Right? Now, if the first item in the list is 1, what could the second item be? Well, the second item in the list must come from set B. So we have 2 choices for that, either 2 or 5. So let's choose 2. Let's pick 2. Let's go further. The third item in the list, the third item in the list, it has to come from C, because we say that x3 must be an element of C. So, well, for C, it's easy. We only have one option. It's got to be 6. So that's 6. That's the third item in the list. And the fourth item in the list, it has to come from D. So it could either be 3 or 7. Let's pick 7. Well, now we have obviously other options, because we can have the same 1, 2, 6, wait, that's a mistake. Hold on. Okay, so that was the first list that we formed. But then obviously we have other choices. So for example, the last item in the list didn't have to be 3. It could have been 7, right? It just has to be something from D. So here we have a different pair, same as before, 1, 2, 6 at the beginning, but then it has, instead of a 3 at the end, it has a 7. But now we can make other choices. Well, so we did the 2 choices for D. We only have 1 choice for C, so we did that already. But then in B, we have 2 choices. So far, we only used 2, the element 2 from B, but we didn't use 5. So we can use 5 now. So here we have 2 more possibilities where instead of using 2, we're using 5. Again, here at the end, we have 6, 3 or 6, 7. But now we realize, hey, the whole time we've only been using 1 as our first item. And that's one of the options from set A, but there are actually 2 other options, 2 and 3. So we have lots of more possibilities. Oh, that's a little mistake. Should not have a comma there. Okay, so that's the answer. Again, it's the Cartesian product is a set of either ordered pairs or more generally a set of lists. As we see here, this is a set. And each item in the set, each element of the set is a list. Okay, a related idea is the idea of a Cartesian power. So the Cartesian power of a set S, denoted S to the power of n, where n is any natural number, is defined as S to the power of n equals S times S times S, or S cross S cross S, meaning the Cartesian product of S with itself n times. Which, in other words, in other symbols, is every possible list of length n, such that x1 and x2 and x3 all the way through xn are all elements of S. So remember this notation where we have a bunch of things separated by commas, element of S. What it means is that x1 is an element of S, and x2 is an element of S, and everything else here is an element of S, and xn is an element of S. So if you can create what you want to do is create a set of all possible lists of length n, where each element in those lists comes from set S. So for example, if we flip a coin once, the set of possible outcomes has two elements, the set h comma t, right? H for heads, t for tails, right? Flip a coin once, you have two possible outcomes. Now, if you flip a coin 7 times in a row, you have a lot more than two outcomes, right? The set of possible outcomes is the Cartesian product of the set h comma t. It's the set h comma t to the power, sorry, not the Cartesian product, rather the Cartesian power, right? The Cartesian power, the set h comma t to the power of 7. Okay, so what are some elements of this set? So for example, one element of this set is the following list: h comma t comma h comma h comma h comma t comma t. This is a list of length 7, and each element of the list, each item in the list is an element of the set h comma t. So therefore, this list is an element of the Cartesian power h comma t to the power of 7. Okay. Now we go on to the new topic in the next video.